But super excited to be here today and start talking about the history behind crypto. So, what I want to do first before getting into the lecture slides is just to go over the architecture syllabus, just to orient ourselves and make sure that everything is super clear. Here is the syllabus, and as we kind of mentioned yesterday, we will be having office hours. So my office hours are standing office for hours between Wednesday 10 to 12 p.m. and 6 to 8 p.m. Eastern Standard Time. So if those don't really work for you, please reach out to me. I am more than happy to be flexible and figure out a time that works. So one thing that I found super helpful as my time teaching was to set up mandatory check-ins. These can be super small time, like 5 minutes, 2 minutes, however long you feel. I just want to make sure that everything is super clear, and if everything's good, that's awesome. My main thing is I don't want to feel as though that I'm not accessible to folks that may have questions. So over here on this widget, you can schedule in those office hours through my Calendly page. And when you scroll down, you can pick a day. You'll fill in your information with email, and then you'll get the Google Meet link, and we'll go from there. So I'm sure most of you have read the course description and recommended preparation. Don't really need to go too much over that since we kind of talked about it the other day. But down here with the required and recommended readings, I will be populating this with both required and recommended readings throughout our time. And please peruse if you want. If you don't and want to wait until we cover it in class, that's also cool and fine as well. Most of them are linked. I did send out an email with the Drive link for the Distributed Labs Volume 1. That is a textbook, so I can't share the actual link to it, but please download it at your convenience. And also let me know if that is hard for you to download. I can figure out a way to send it to you outside of that. So on this,
real quick, just want to pause. Can we share this link out with people? I think it should be publicly viewable. So I could just drop it in the chat here.
Yeah, that'd be great. Thank you.
Okay.
So you'll note that on the side, the REQ means required, and the 3 asterisks are optional, but we'll be covering them in class. So if you want to dig more deeply into them, they're right there for you. And we'll get into the research how-to template a little bit later, but what I want to really focus on is the schedule. So here, I'm notorious for updating all the time. So if you click on the actual page, it will open up to the week that we will be starting at. So I will more than likely have the schedule of events for folks to, if you know that you're going to be busy at certain times, you can kind of figure out which part of the lecture you want to pay attention to more. And my actual Canvas slides will be here as well, and the rest of my lecture notes. So all of the info that I'll be talking about will be right here in this Notion page, and I will also send it out as a PDF for folks. So with that, I want to leave the home review and deliverables for the end, since it doesn't really make sense to talk about them in the beginning when we are just about to get started with the lecture. But with that, I do want to see if anyone has any questions. Let me stop the share so I can see y'all.
Yeah, and feel free to just unmute if you wanna pose a question.
You guys, I came 3 minutes late, and I don't know whether we discussed about engineering track. I guess for the first week, engineering and architecture track would be the same. So would we be using the same link, or is there a different link for engineering syllabus?
Yeah, sure. So we haven't talked about engineering track yet, but For this weekend, they are together, so they're the same. For next weekend, they'll be different. So we will send out different like Zoom link. So you'll go to two different places for next week. And I'll
Okay.
share out the link to the syllabus for the engineering track in a second.
Yeah, awesome. Thank you.
Any other questions from folks?
My question was answered, yes.
So,
When we signed up, there was an option to do both tracks, but it's not going to work that way this time around. So would it be possible, like, would we be eligible to do the one track in this season and then apply for a later season to do the other track?
Yeah, absolutely. Yeah, so because of timing, it's not possible to do both right now. There's just a lot of material in both tracks, and limited amount of time. But definitely, like anyone here who is doing season 0 is welcome to do any future season that we have, and you're welcome to do any track that you want in those future seasons as well.
any other questions? All right. So one thing before I go into the schedule of events, I do like to structure my lectures in terms of giving you all history, and this will be a history-oriented lecture, in addition to working on the blockchain fundamentals that'll come in the second half of this lecture. There will be times where we are going to break out into groups, and there will be questions that you'll work out within your group. And I think the most fun part of today is we are going to work on deciphering and pulling apart the Bitcoin white paper in small groups. So that is the fun thing for today. Okay. All right. So for the schedule of events, first, we reviewed the Notion page. We're going to dive into an introduction for today's topics and kind of parse out what it means to be and work and think in this space. After that, we're going to go into our first group activity where we will break out into groups for about 15 to 20 minutes. After that, we're going to come back as a large group and just talk about what we had talked about in our groups and kind of discuss that openly. After that, we're going to break down some more manifestos within the crypto space and break for questions. You'll have time to go get coffee. I know I'll be getting coffee, and you'll come back and whatever questions you have, you can come and talk to me during that break. After that, we'll be kind of diving more into the technical aspects of blockchain fundamentals, and I will be kind of discussing what vocabulary to kind of keep sight of as you continue on your journey today. So just gonna orient myself a bit. All right. So I am not sure how much folks know about the cypherpunk movement, but one thing that really kind of has stuck with me for the longest time is one of the notable founders of the movement, St. Jude, or Jude Milhone. She was a civil rights activist and self-taught programmer born in Washington, D.C. That is her mugshot on the left-hand side of the screen. She was arrested during the civil rights march in Jackson, Mississippi. So she was super cool. Not only was she very active within the civil rights movement, she was part of the counterculture movement as well. And she kind of coined the term cypherpunk. And this kind of movement and rebellion that she created happened around the 1970s. That combines this philosophical tradition of crypto anarchism, where kind of all laws and regulations are replaced by mathematically verifiable code. So with Jude, or St. Jude as she was called, you have David Chaum, who talked about digital cash, Eric Hughes, who wrote the Cypherpunk Manifesto, and Timothy C. May, who wrote the Crypto Anarchist Manifesto. So today we'll be kind of diving into the manifestos of Hughes and May. But I did want to start off with St. Jude because she's often left out, which I think is very telling, that a woman whose occupation was a housewife was left out of the movement.
Yeah, so Aaron just posed a really great question. Like, why do we hear so much about everyone else and less about St. Jude? Just wondering if you have like any quick thoughts on that.
Yeah, honestly, I I think that it might have been a lot of misogyny within the space. I know that she was a part of the counterculture movement, and there were, the births of like third and second wave feminism happening. But honestly, when I started learning about the space, I didn't know about St. Jude until I dug around some more. I first learned about Hughes in May, so I'm not sure if it's just what happens with history. You kind of only really hear about the men, the white men in the space, and not the other folks. But that's just my guess. Any other questions? So the first manifesto that we are going to dive into is Eric Hughes with the Cypherpunk Manifesto. And I will be breaking down kind of just the basics of what he's talking about. And this is a very short piece that we'll start to break down within our groups. So I really like this quote that he writes about, where he says, "We cannot expect governments, corporations, or other large faceless organizations to grant us privacy out of their beneficence. It is to their advantage to speak of us, and we should expect that they will speak." So kind of breaking this down, he writes about the changing landscape of Web 1.0 and what he believes to be is the encroachment of third parties on private conversations. So I really want to highlight this because this is what is going to start kind of building those road blocks, so to speak, to the Bitcoin white paper. So there's this, I would say, not paranoia, but an observation that the networks that we are creating on the internet are slowly being kind of influenced by these third parties that may not even need to be a part of the community that's being built. So outside of that, I would say three main points of Hughes's argument is that privacy is the basis of an open society. And I really want to break that down because I am a huge privacy advocate. I work with privacy enhancing technology. So I think a lot of folks tend to kind of not realize how important privacy is. We can think of things as simple as clothes. That's a form of privacy. Closing the blinds at the end of the day is privacy as well. It's something that we use to help us feel, I would say, safe and secure in our spaces. And that privacy has morphed as the internet has grown. So in addition to that point, he also discusses anonymous transaction systems. So this is very interesting because he says that he doesn't want it predicated on secrecy, but where the individual can reveal their identity when they want. Again, super interesting that he's talking about an anonymous transaction system, the encroachment of third parties. We're kind of building the blocks for that language within the Bitcoin white paper that we'll see a lot later. And then he talks about this idea that this widely distributed, dispersed system cannot be shut down. So this is something that May will point to and discuss a lot in his text, but this also speaks to the idea that centralized authorities may not even be able to shut down these distributed systems because it's very hard to do. It's not centralized. Okay, so with our first kind of small group task, I am going to break all up into small groups. I'm going to post the link for the paper, and we're going to talk about a couple of the questions that I have here. What is privacy for you all, and how do we recreate privacy within our current systems? And this can be either a philosophical answer or an objective answer, whatever you want. And we're going to bring back those observations to the group and discuss May's writing. So I'm going to stop the share and get the link for you all. And while I'm doing that, does anyone have any questions or just any initial thoughts?
Yeah, I have an initial thought. I'm also pretty big on privacy. And a lot of the time I feel like I'm fighting an uphill battle and that people think I'm pretty paranoid. And so it's really great to kind of read these texts and to have other people read this text and to be able to discuss them, because privacy is at the heart of what it means to be human. It's a pretty well discussed philosophical topic as well. Yeah, so it's super important to preserve a space where you can turn inwards and reflect. Part of what it means to be human is the ability to reflect. And if you can't have that space, you also are very open to being manipulated. So thanks for the discussion.
So I thank you for the comment. I'm glad that we're sparking this conversation. It is, as you said, super important, and we're actually going to deconstruct this kind of tension we see within another text that I think is really smart and really tells a lot of the discussions that we are now having in the space right now. So I'm going to put around 4 participants per room. And all right, all the rooms should be open. I will post the questions again and we'll go from there. But as folks come back, I did want to make note of another really interesting book. I have the PDF of it. It's called Surveillance Capitalism by Shoshana Zuboff. And she basically writes about our current state of affairs with having our data sold to third parties and kind of just increasing consumerism, and very fun read if this is your type of stuff. Okay, so I do want to make this very informal. Are there any kind of big takeaways that the groups talked about that you want to bring to the main group? And if not, also cool, but would love to hear some thoughts from folks.
Yeah, I can give some thoughts. So I basically shared with the group a few articles. It was actually more like a Twitter thread I read about. It was called how to delete yourself from the internet and become a digital ghost. That was basically the name of the thread. And yeah, I think I'm gonna share it with the group. It really shows how difficult, and that is one of the takeaways we had in our group, how difficult it is with the current system to actually be private online. Even your digital signature is definitely in everything you've done since you first came into knowledge of the internet. And there's another thing that I wanted to share, that you actually can check if any email you ever had has been part of a security breach. And I'm also going to share that website with you so you can check. And both of those things definitely show how privacy is always difficult, if not impossible. Even if you did everything in your power to stay private, you're always in contact, your parents maybe don't know so much, your friends, through the other people around you, you're definitely always that, maybe not that private as you would like to be. So yeah, I think the alternative to that cannot be the current system, what is called the Web 2 system, but the alternative is outside of that. And I think that's what most people believe and are creating at the moment. So I'm definitely gonna leave both of those links so you can definitely check that out.
Awesome, thank you. Anyone
So we discussed about anonymous data collection, and it's still a way where businesses and everyone can analyze and target us in a way, but anonymous data collection makes us feel less intrusive, and it's a little bit more comfortable than having our name out there, having a profile on us and a whole case file on us then. So our group agreed a little bit on that. And yeah, I would like to share that with the team.
We'll have time for one more before we get into the next part.
I can go. In our group, we talked about mostly one of the side effects of lack of privacy being your data be getting collected, and we addressed some solutions that we thought could work while acknowledging the cons for the solutions. One would be maybe use paid services, and maybe that way you can leverage hey, you can't use my data however you want, because if you're not paying for the service, you're the product. The other one that we talked about was, okay, maybe not necessarily pay for services, but it should be a morality issue where, as opposed to me agreeing to a site saying I collect your data, etc., how about they agree to my rules as a human being that you should not use my data, etc. So it shouldn't be me agreeing to their rules, but then maybe agreeing to us. I don't know if there was something in Europe that was passed like a couple of years ago related to that. Yeah, that's what we talked about.
Awesome. I do, I guess, since there's a lot of interest for this, I will think about incorporating zero knowledge proofing. And this is the part of cryptography that I work with on a daily basis. So since we're talking about, we have both the engineering and architecture track, I will try to incorporate some more zero knowledge proofing techniques that we can talk about in later sessions. But for now, we're going to continue on with diving deeper into history. So fast forward to probably about a year or so later, we have Timothy C. May, another cypherpunk in the scene who is also thinking about the similar things that Hughes had. Privacy as open society, the threat of centralized authorities, and how we can actually make these things a reality. So he is very similar to Hughes in that he writes about this specter of state intervention on the internet. And he then kind of talks about how, two individuals can exchange messages, conduct business, and negotiate electronic contracts without ever knowing the true name or legal identity of the other. And this piece I find super interesting because this is kind of the proto thinking to smart contracts and the further developments within the space. So one thing that I do love about May's piece is that he then talks about how the power of cryptography can be used to create social and political change. So I do want you all to keep this in mind as we move toward where crypto is today. Can we still actually use what Hughes and May talks about to create the systems that they dreamed about? And if not, where do you think these ideas have been lost and how do we get those back? So fast forward to 2013, we have a two-parter. What Happened to the Crypto Dream by Arvind Narayan. And this being published in 2013 is right after, not right after, but a couple years after the publication of the Bitcoin white paper in 2008. So you have this whole history of kind of crypto text from Hughes to May and then Satoshi. So you have this author really kind of thinking about the implications of those texts and then this technology that has been kind of birthed into existence. So I want to kind of break down the dreams, I guess the two dreams that he writes about. The first being, in the early 2000s, you have the advancement in microcomputing, which paved the way for the revolutions to kind of the crypto dream that Hughes and May wrote about. And you have these two notions of crypto for security versus crypto for privacy. And to break those definitions down, crypto for privacy is the social and politically focused crypto movement. And that is most aptly seen through David Chaum's work with digital cash. So he writes about the making Big Brother obsolete. It's actually in his title. It's called Security Without Identification, Transaction Systems to Make Big Brother Obsolete, which I can also link in the chat today if folks really want to get into it. Then you have the crypto for security, which we are definitely more familiar with. This is protecting one's assets. So, you have, for an example, the encryption of credit cards. That's a secure mechanism that we use today. So in the second part, he then talks about the cypherpunk crypto versus pragmatic crypto. And this is what we have really been kind of wrestling with for the past 30 minutes, right? So there are things that we have to weigh in our current systems. We are weighing the demand for privacy. Privacy is complex given the social and political systems that we work around. And there is this divide between non-technical and technical people's willingness to dive into privacy enhancing technologies. So I'd heard a couple of folks talk about and even discuss that, you know, we are so used to using centralized authorities such as Google with our Drive, our email, etc., search engine, that it makes us hard to untether ourselves from those systems. So what you have are these mismatched economic models. You have these two competing theories of I want my privacy, but it's so hard to get it because these centralized authorities make it so easy. And the manufacturing of kind of window dressed security is not the same as privacy, right? So I know that Google has a couple times where they ask you to update your terms of privacy to make sure that, you know, your privacy settings are the way that you want them, but is it actually private? Not really. So with this, there is also this kind of third layer that the author talks about being at the technical core. The cypherpunk crypto and pragmatic crypto may evidence as the same, but are they the same socially and politically? And what implications does this have for those who assume that they are technically the same? Is the social output the same? Where does this assumption get us into trouble, and how do we correct course? So these are some of the similar questions that Hughes and May were talking about, but at a grander scale, because this is a new iteration of the internet. So with all of that, I do want to take a quick 15-minute break for folks.
I have a question. This is pretty basic, but I don't want to get like lost in all the jargon. Can you explain, is cryptography the building blocks of the internet itself, or the system of transaction between two people?
So I would say cryptography is something entirely different. You can kind of think of it as a part of a social and political movement, but cryptography at its core is the study of mathematical proofs to kind of shield or create privacy in secure systems. And we'll get into that after the break and kind of how we can use these definitions. I know I threw a lot of terms at all of you today, this morning. So I will share my tips on how to kind of, you know, keep these definitions in your head while also balancing what is this person actually talking about, because I feel like folks use the term crypto very loosely, you know, so yeah.
Cool, thank you. Yeah, I tried to look it up, but like the words within the definition were confusing. So I appreciate your definition. Thank you.
Yeah, I think just to ad-lib a little bit in there too, I think that a good way to kind of understand it as well is, like Gabrielle said, like it's about math and it's about these mathematical proofs, but also like it can be applied to so many different things in our life. So it can be applied to the way we exchange information, like as a message, or the way we send money to each other, or the way we identify a website. So like cryptography is used every time you hit some URL, you're using cryptography. Like it's applied in so many aspects of our life, and can be applied in like physical space as well, to some degree. So you can have, cryptography involved in a phone call, or even just written by hand on paper. So that's why it can be kind of confusing, I think, in the beginning to understand like where does it start and end, because it's associated so often with like cryptocurrency, but that's like only one small application out of like a very wide array of different things you can do with cryptography itself.
I guess we can say cryptography is a simple way to share the information to only the intended users.
Yeah, it can definitely be used for that. There's other applications as well, where, like signatures, for example, right? You could use cryptography to create a signature, and that might not be a way of having privacy per se, but it's a way of, having some mathematical guarantee about the information that you're using. Yeah, there's also like a ton of for people who are listening into, there's a ton of work being done on homomorphic encryption, which is like a method within cryptography so that you can create like operations on data in a private way. So I think someone brought up like doing anonymous, like collecting data anonymously, and things like homomorphic encryption allow you to like do analysis on data anonymously, which is really powerful. And there's a lot of things like that, a lot of like tools that are being developed in that realm as well. In addition to zero knowledge stuff. And what was the other thing? Multi-party computation. I feel like that's still like kind of far away. So basically like multi-party computation, having like multiple people do a tiny piece of some computation so that they don't actually know the data that they're operating on, but they're still like contributing to the end result. That's still kind of far away, I think. I don't know, I haven't really been like staying up to date with it, but also I saw Aaron's note about the Women Who Code blockchain group, which is very cool that that's still going. When I started in the space in, well, around 2018, I guess, is when I got into the Women Who Code group, and started doing some blockchain events with them, which was fun when I was living in San Francisco. So that, yeah, I found in general, like I found some good friends through Women Who Code organizations. So those have been fun.
Also, for folks that are listening, I do not care if you have to eat or drink. Like, this is not formal. Please eat if you need to.
Yes, thank you to all the West Coast people for being up so early with us.
Yeah, wow.
5:30 a.m. More power to you. We're definitely going to try to make it worth your while.
Yeah. Again, with the office hours, depending on time zone situations, I am like very, very flexible. I work with a German company, so like I feel like my time zone is on European time, so I don't even know what time zone I live in really. So please, I am more than willing to move around stuff.
Yeah, also in general, if people do have like find things confusing or have questions that you feel like are really basic, like definitely ask them, because you're not the only one who's confused probably by something. And like we have a range of people who have a range of experiences and backgrounds. Some people might be familiar with some of the terminology already, others may not. So we want to make sure that if there is anything that's unfamiliar or you just don't understand what a word means, like definitely ask about it.
I have a question for Val on the engineering track. I think I asked earlier, like, what's the deliverables, I guess, expected versus like a blog post, like a technical blog versus like a GitHub repo. I'm so used to like having courses like you need to do a lab, and then when I avoid it, it's just like, well, I watched all the videos. Did you actually build a project? Like I've had like books on Solidity sitting in my Kindle, and I'm always like, why are you avoiding this? I'm like, you actually really need to go code, like more of a prototype. So I think that's my biggest like barrier. I was wondering like what requirements are there. It's always helpful to have, and while we don't have them, like that's also okay. I just want to make sure like I'm trying to make sure I meet, the expectations, if that makes sense.
Yeah, sure. Yeah, so mostly it will be coding like deliverables. And kind of the way that it's set up is like most of the kind of technical teaching is going to be done on Saturday, and then Sunday will be time together to do like pair programming and actually start your implementation. And then by the next Friday, that implementation will be kind of due as a deliverable. But all of it will be proofs of concept. Like the expectation is not to have like an app that is in production, right? It's just something that someone can go to GitHub or wherever else you host it, clone that and run it and get an example of what you were trying to achieve. So yeah, they mostly will be, or maybe entirely, coding deliverables. And then, if you have any like concerns or questions about that, we can definitely talk about it.
Well, I think if no one else has any questions about any of the tracks or just other general questions, I'm going to go ahead and start the part 2 of our lecture today. Okay, so we are going to get into blockchain finally. So to preface this before we kind of get into the fundamentals, I do want to say that there are going to be a lot of definitions and new vocabulary thrown your way. So what I recommend in general is to, however you learn, I would just write down or maybe type out what definitions you still don't have clarity on, or ones that interest you. Basically, anything that you may want to dive deeper into, just make a log of it and go back to it and return to it however often you want to. So a lot of the terms between this slide and the next slide will be talked about not only in this session, but also in the upcoming sessions. And we're not going to be able to get too into a lot of the definitions on the next slide, but I say that just to warn folks. And the goal of today is to provide a cushy foundation of what are we actually talking about, and from there we can build off of that and learn a little bit more about those other concepts or vocabulary words that we may have not gotten to today. So with that, we are going to dive in. So you'll see on the right-hand side of the slide, I do want to emphasize that you may hear a lot of folks saying that blockchain is distributed ledger technology. That is actually a huge misnomer. So blockchain is a form of DLT, but DLT is not blockchain. And when you see this, kind of red flag it. If you are reading about blockchain online, probably not a reputable source. Yeah, so what I plan on doing for the left-hand side of the slides for this one is to break it down from talk about the technical side of it and do a real life example, because I know that a lot of this is very abstract, and without a connection to something physical, it can seem possibly unattainable to conceptualize of. So with that, let's get into it. So blockchain primitives. As I said, distributed ledger technology is not blockchain. Rather, it is a database that is spread and synchronized across various areas. Distributed ledger technology is often written as DLT. And DLT is not the same as blockchain, rather it's a form. So in real life, we encounter these ledgers all the time. One thing that is most often kind of as a ledger is a receipt. So my partner just got me a coffee and bagel. That receipt of that coffee and bagel has the product type, the transaction type, the time at which they got it, and the other the location of the cafe. So that is a form of a ledger. Next on the list, I have atomic. So what do I mean by atomic? By this, I mean that all transactions are indivisible, right? So either all transactions occur or none occur. So let's think about it in that real life example. So say that my partner goes to buy that coffee and bagel. And what will happen is either the transaction will go through, it's accepted and it goes through, they receive the coffee and the bagel, or the card gets declined and I do not get the coffee and bagel. So you can kind of think of these transactions either happening or not happening. There's no in between. Next, you have the transparency aspect. Technically, this means that all transactions are viewable. Nothing is really hidden from the users of the blockchain, depending on which blockchain we are talking about. And you can actually test this out in real life. So there are places such as Etherscan, where you can actually view the ledger of transactions taking place on Ether mainnet. So we can play along with that a little bit later today if we have time. But these are kind of those physical representations of these very abstract concepts. And how does all of this make sense within blockchain? So these components, the atomic nature of transactions, the transparency, the very crux of it being a distributed ledger technology, is the fundamentals of blockchain. So next, we're going to dive into the types of blockchains that are available now. The first is public. And with each of these examples, each of these definitions, I will give an example of what they are and how you can interact with them. So a public blockchain is one where anyone can join and participate. And the two biggest ones that folks may already know are Ethereum and Bitcoin. Next, you have private blockchains, and these are blockchains where you have to be basically invited to join. And usually private blockchains are used for testing and development. And for those on the engineering track, I'm sure that you will be using private blockchains for testing and development. Next, you have the federated or consortium blockchains. And one of those is Hyperledger for folks who may or may not be familiar. So these federated blockchains are owned by a group. And these are only accessible by those folks that are in the group. So to kind of break it down even further, you would use a federated blockchain for specific use cases like financial services, insurance claims, or even nuclear arsenal claims, which is a fun use case that I can talk about later if folks have questions about that. And the last type we have is a hybrid. So a hybrid is a combination of public and private. And the difference really stems from that certain users are able to access certain aspects, certain areas of that blockchain. Before we get into consensus algorithms, does anyone have any questions? And please shout them out since I can't really see if folks are raising their hands.
I had a question about Cosmos. I had a bunch of friends that work there, and I was talking with my friend who's the CEO of Harmony, Li Jiang, and I was like, oh, so what you're doing is like XYZ, like what Cosmos is doing. They're like, no, that's Tendermint or that's internal. And I was getting confused because I know Cosmos has a number of like competitors, not too many, but I guess the way that I understood them is that they're more federated rather than something that's more public or hybrid. I always get really confused because there's so many different acronyms in this space of like who's competing against who, whether it's like I built XYZ on, you know, a Polkadot using Substrate and this framework and front end. And I'm like, which thing am I? And then it gets, I don't know, anyone who's not an engineer will probably, it'll just go over their head. And so I'm just curious to know, like, if there are other examples, like I wish I had an infographic of like different companies of which is what.
Yeah, I mean, so I don't have a ton of like expertise in terms of Tendermint consensus. I know that it exists and that it's based on staking. So basically, for folks who are completely unfamiliar with Tendermint and staking and things like that. So we're going to talk about proof of stake in a second when we get to the consensus algorithms. But basically, like different types of blockchains use different forms of consensus. So Cosmos, as an example, uses a form of consensus called proof of stake. Bitcoin uses a form of consensus called proof of work. And so people are kind of creating all these different iterations, right, of blockchains that use slightly different things and have slightly different behaviors. In terms of Cosmos, I don't know for sure if it's federated or not. My understanding is it's public. That could be wrong. So I would have to learn more about specifically what Cosmos is doing. But one of the kind of things that people like to do with these blockchains, especially ones that use different types of consensus algorithms, is like what's called sharding. And so basically they create kind of miniature sub blockchains almost that are kind of like attached to a single one, which is bigger. And so Cosmos, as an example, is trying to kind of provide a way to scale their system by doing something similar to that. So now, instead of just having one blockchain, you can kind of have multiple almost that allow you to scale. So in terms of that, like that might be the conversation that you were having with the person. I don't know for sure, but I do believe it's public, and I know that it's the Tendermint consensus is based on proof of stake. Hopefully that helps.
All right, so let's get into the consensus algorithms. And I will say, I know that, again, I'm throwing a lot of information at you, and I know that folks learn differently. So we will be viewing a video after talking about the consensus algorithms, just to kind of put these things to pictures and words and voices that are not my voice. So hopefully that will help too. All right, so down here at the bottom of the slide, we have consensus algorithms. So there are tons of different consensus algorithms, and please do not try to learn all of them. I would say there are a lot more than what I have listed here. But I would say the three that you'll see the most would be proof of work, proof of stake, and proof of authority. So the first is proof of work, where basically the block validator or miner is using the computational energy of a computer to solve a cryptographic puzzle. With proof of stake, you are using the tokens held by the block validator to reach consensus. And the last one, you have a centralized authority to achieve agreement. And consensus equals agreement among the space. Consensus is just the term that's used. So let's kind of get into the actual language. And you'll see a lot of terms that you may not know right now, but again, we will get into it a little bit later today. So
sorry, real quick, someone just asked, can you repeat, I think the proof of work, proof of stake things again, briefly?
Yes. So first, proof of work, you are using the computational energy of a computer to solve a cryptographic puzzle. And we will be diving into a proof of work example after this slide and additionally in the video. Proof of stake is a little bit different. And this is what Ethereum is working towards. If you're in the space, you've kind of learned that, that's what their goal is, to achieve a proof of stake consensus algorithm. So proof of stake, you are using the tokens held by the block validators to reach an agreement, basically. So again, I'm using very generalizable, non-technical terms to define these consensus algorithms, because I just want to set a very basic foundation for folks to kind of at least grasp the concept of the term first. So before we walk through an example, I do want to highlight what's on the slide currently. So as you read about the mechanisms and other consensus algorithms, you'll see a lot of this language. And I've broken it down between governance and technical concepts. So you may see a lot of words like tokenomics or governance economic, governance, block validator, miner, and you'll meet Alice and Bob, the two folks who you will become very good friends with throughout this course and throughout your time in the Web3 space. The technical concepts are also things that you will see as you read. And depending on how deep within the space you want to get, you'll learn more about these terms. So just to kind of put those out there, you'll hear things like node, nonce, tokens, the difficulty, hashing, SHA-256, KSAC-256, the transaction root, Merkle trees, Patricia trees, mempool, and private and public key. So some of these we will actually be touching on in the next week's session. So I don't want to get too into them, but just want to make them known that here are the concepts and words that you will be seeing. So to kind of, again, tether this idea of consensus to something that may be a little more accessible to folks, I do want to set a scene of consensus. So imagine that you and your friend are going to go and have some fun tonight. You decide, hey, let's go to the bingo hall and let's try and let's see if we can win a prize tonight. So you all go to the bingo hall and they are actually, the prize will be a whole Bitcoin. So before we actually see who will actually win, what happens? So a person in a feather boa will kind of roll onto stage with the kind of the mechanism that turns all the balls with the numbers on them. And this person yells out different combinations. So the first combination is A34. All of the participants in the bingo hall write down A34. The same thing happens for the next ball that this person pulls out, R56, U89, and I22. Eventually, you hear your lucky friend yell, bingo. And this person, your friend, your very lucky friend, wins one whole Bitcoin. So how does this actually relate to consensus as a proof of work concept specifically? So in the space, there is this idea and kind of rule that the longest chain wins. So your friend, if you are familiar with bingo, they got all of the combinations correct. They had the longest chain of correct transactions. So that proves that the amount of work that they put in solving it, that they got it right. So you can kind of take this very, very loose general example into thinking about how proof of work actually happens. So with this, we are going to watch a short little video on visualizing consensus, and we will then break it down a little bit further and talk about what it actually looks like in a diagram, just to orient folks who may be more interested in looking at a diagram. And as I do that for a second and see if there are any questions. So I am going to post the link in the chat because I know it's always really tough watching a video through Zoom. We're gonna watch this 6-minute video. And for folks who may be on their mobile device, I can also play it on here, but just let me know. But here is the video. We are going to come back together as a group after folks are done watching it. So, and then we're gonna have questions and answers after that. So for folks that have come back, I do want to pause here and just have a discussion and just questions and trying to answer any of those questions you may have. So, but as we go further into actually reading the Bitcoin white paper today, that, you know, we don't have to, that we can just express them right now to make it a little bit easier. Okay, so one question is a node a special name for the individual people in the peer-to-peer network? And yes, I would say that is a special term used. You can kind of think about it as, I might put a diagram up here just to make folks visualize it. But basically, you can kind of think of these nodes as being spread out across the network, right? And those nodes are going to be participating in that peer-to-peer network. Does that kind of clarify that?
I have a question.
Mm-hmm.
So when in the video, they were talking about how in the proof of work, there's something like 10 minutes and then 10 minutes for like the next block. And it's like part of their way of slowing down the proof that enhances the security of it. And then you were saying how Ethereum is moving to a proof of stake. And I know from having worked on a different blockchain about like how they were also kind of just upgrading so that each block is like taking less time. So does that like make it less secure, or just like, I'm trying to suss out because I don't fully understand like the like slowing down the speed makes it more secure, but then I also hear that like they're trying to make it faster per block added for transactions to occur more frequently.
Yeah, so let me break down the time aspect, because I think that's something that you'll also see as you read. So on Bitcoin and the Bitcoin mainnet, a completed block usually takes about 10 to 15 minutes. For other blockchains like Ethereum, it is a lot faster. I believe around 20 to 30 seconds, if I'm not mistaken. So you'll see there, if you go and read about this timing aspect and the security of it, you'll hear a lot of Bitcoin Core folks talk about this notion of halving, because halving, and I'm not a Bitcoin Core expert at all, but because Bitcoin uses a proof of work consensus algorithm, it's using a lot of computational energy. Proof of stake, which Ethereum wants to move to, does not use as much computational energy. And with that, you can kind of picture these nodes that are using up a lot of energy, right? And what has been kind of observed within the space, especially for blockchains that run on proof of work, is that you have these kind of these pools, these mining pools, where the transaction it's more likely for it to be found in that area instead of another kind of area that's far away from that mining pool. So there were a lot of talks about how do we actually lessen that, because with that, there is a potential kind of security flaw with that. And we'll talk a little bit about the secureness of blockchains, because I do think that a lot of the language surrounding security in blockchain makes it seem as though it's this incredibly secure system that can never fail, and that is very wrong. There are tons of things that can happen with that. So that was the first part of your question. The second part, can you repeat that?
Yeah, so when, like Val said, they aim for 15 seconds in Ethereum and 10 minutes on Bitcoin per block, does like it being faster for each transaction to complete per block make it less secure? If in the video they were talking about like one way of making it secure is like slowing down the speed.
Yeah.
Don't fully understand.
Yeah, I think I can add in here too. Like, so there is definitely a trade-off that's made between speed and security. And that's, you know, there's a trifecta of this trade-off. But anyway, so between speed and security, there is a trade-off. And essentially what happens is like computers over time get a lot better at doing these computations that contribute to proof of work, right? So Bitcoin has been around since 2009 officially, January, sorry, of 2009. We're now at 2021. Computers have gotten a lot better, and the machines are optimized for doing the sort of proof of work that is required, right? And so by kind of keeping this time to around 10 minutes, what they're doing is trying to make the difficulty of doing the computation relatively consistent over time. So the difficulty was much like easier, you know, in 2009 than it is today, but the time frame stays the same. So what's changing is kind of the proof that you need to generate underneath that. And so controlling the time is a way of controlling difficulty, which controls how easy, you know, or hard it is to generate new blocks, and that contributes to the security of the chain. I think it's similar in Ethereum. I'm not 100% positive, but at least for Bitcoin, that is, you know, a factor that goes into the security. So does that cover your question, or was there another piece?
Yeah, no, thanks.
Okay, I'm going to go up to one of the comments in the chat about the climate question with these proof of X consensus algorithms. So that is another argument that you'll see in this space. And I will say that the way that the discussion around climate and consensus algorithms are made is kind of flawed because, as one person noted, you know, proof of stake takes less energy than proof of work. But with that, there are ways to make sure that the energy consumption is using clean energy, right? So there are foreign governments that are actually using a lot of renewable energy to power these mining rigs. So there's also this other argument that because blockchain and cryptocurrency is a new hot topic and that folks are still kind of grappling with what it actually means, there's a lot of misplacement of the climate question because people tend to not think about how much energy the servers used by, you know, Google, Facebook, etc., are using tons of energy all the time, in addition to our traditional banking system that also uses a lot of energy. And when you compare that to the energy used or needed to be used for cryptocurrency and blockchains in general, it just doesn't compare really. So it's a very misplaced argument. Let's see.
Another good question that Gabriella had: what happens when a chain is found to be tampered with, and how does it recover?
Okay, so what I want to do with that question is basically talk about what happens when there is kind of a disagreement within the space. So there are a couple of things that can happen. you can either have basically a split or a fork in the chain. And this is a concept that you can read about further, but with a fork, you have two different types of forks that can happen, a hard fork and a soft fork. A hard fork you can think of as being where the governance within the community basically says, hey, I don't really like what's happening. We're going to create our own kind of fork off of this main one, and it's not backwards compatible. They cannot go back to the older system. They have a new system that they want to use going forward, and that's their thing. With a soft fork, it's a little less extreme. There can still be a little disagreement within this space, but it is backwards compatible. Then you have what you call a split. So this is something that I don't think the video touched on, but let's say two block validators validate the exact same block at the same time. They both find one. That's called a split. So I want to stop there because there are two things that can happen depending on what we're talking about. If we're talking about the Bitcoin mainnet, there is a governance structure that happens. And then with Ethereum, there's a different governance structure that happens if that split occurs. But those are kind of the three options that usually occur. I don't know, Val, if you want anything to offer.
To add to that, the kind of like the second part of the question, how does it recover? So basically, and I think we'll get into this a little bit deeper, but basically kind of consensus, like it doesn't occur like instantaneously, it like occurs over time. So let's say you have 100 nodes in the network, right? In order for the entire network to reach consensus, all 100 nodes have to have the same exact data for all blocks in the chain, right? And then at that point, we can say, okay, if 100 nodes all have the same data, they have reached 100% consensus. But that doesn't happen like immediately, so it kind of takes time. So what happens when, if there is a block that is proposed as being added to the chain, people will verify the information in that block and they'll validate that it looks correct based on the specification of the Bitcoin protocol. And if they believe that it looks correct, they will add it to their own copy of the blockchain, right? And so let's say, someone receives a block from another node, they verify it, it gets added to their local copy of the blockchain. They tell the other nodes they're connected to, hey, I just added this new block. And so over time, everyone basically gets the same information and agrees, oh, this is the block that should be added. Now, what can happen is, like Gabrielle was saying, like you can have this kind of split where there's two blocks in the network at the same time that want to take kind of the same position. So let's say it's block number 4. Like there are two block number 4s in the network. 30 people have 4A and 30 people have 4B. Over time, there's going to be some consensus that is reached, and it's going to either take A or B. And just people are going to naturally agree on one or the other based on the spreading of this information. So what could happen, as Gabrielle was saying, is like you could have a fork where they just don't agree, right? And then you just have half of the network is saying, oh, it's 4B, and half the network saying it's 4A. So in terms of like recovering, the consensus like algorithm itself kind of naturally gravitates towards a canonical history. So even if you do have these like 4C, 4D, 4E, eventually those will kind of get dropped, and technically they're called orphan blocks in the Bitcoin protocol. So eventually they just become kind of like they become like obsolete because they don't get added to the canonical chain. So the notion of tampering is, in one sense, it's not really that important, because as long as everyone verifies a block and comes to an agreement that it's a valid block, then that block will get added. And any other blocks that are invalid once they're verified or not added by the entire network, they just get ignored.
Yeah, and to add, Ethereum has something very similar with uncled blocks.
I have a question. So what exactly is tampering a block mean? As far as my understanding goes, we can only create or I don't think we can delete a block, so we can only create and add, right? So what are we tampering with? Say there's a chain which has 10 blocks, and I want to understand what exactly tampering means. Does it mean like tampering with the block number 5, changing some data in it, or deleting it, or something like that, or is it something else?
Yeah, so what I'll do is I want to answer your question, but I also want to answer the question about the 51% attack, and we'll just go into attack vectors.
Yes.
So in the video, they talked about the potential for these things called 51% attacks. And basically what you have, and I'll post this article in here as well for folks to kind of look at their own time, is that you could potentially have a double spend attack through this attack vector, where the nefarious actor really amasses a majority of the hash rate of whatever target cryptocurrency we're talking about, whether that's Ethereum or Bitcoin. So what happens is that attacker has, when you get the majority of the chain, that has implications for basically destabilizing the governance ecosystem, if that makes sense. You don't want someone to have a majority stake of the chain, because then control can be exerted over that particular blockchain. But for different attack vectors, like I said before, a lot of folks may conceptualize as blockchain as this very secure system, but we have to think about who is actually building the code for these blockchains. Humans are. So a lot of these problems or security issues are often kind of first started as just human code errors. And there are tons of different attacks that can occur, not just within blockchains in general, but also for smart contracts and other like cryptocurrencies. There's tons and tons. I don't want to overwhelm folks with the amount of information regarding security on the network, but tampering can happen, you know, through that example with 51% attacks, where someone gains a majority governance of that chain, or it can happen where code is exploited. So I would say those are two general concepts and ideas that you can kind of think about as being ways that bad actors can take over a blockchain.
Yeah, and then to add for the tampering piece as well. So I guess in the video, they kind of explain it like, you know, you have, let's say again, like you have 4 blocks in your chain, right? That fourth block will have some unique like string of characters, which is the hash, and that's like a kind of fingerprint for that block. And that signature or that fingerprint for that block is dependent on all the blocks that came before it. So if someone wanted to tamper the chain, because let's say they, you know, wanted to try to get more money out of a transaction, so what they would attempt to do is, you know, make some change to block 3 where the transaction in question occurred, right? And if they try to change that data, so let's say they instead of saying, you know, the transaction sent 5 Bitcoin, they want to change it to the transaction sent 10 Bitcoin. As soon as they make the change to that data, what they effectively have to do to get it included in the canonical chain is, you know, change the data, regenerate the hash, which is the signature for block 3, and then also regenerate the hash, which is the signature for block 4. Because block 4 depends on block 3, it's going to have a new hash if there is different data behind it. And so that means you now have, this attacker per se, they now have a blockchain that has a different block 3 hash and a different block 4 hash than pretty much everyone else in the network. So if they wanted to get that included in the canonical chain, they would then have to publish to the rest of the nodes that they're connected to their version of the chain. And those nodes would see it and they would say, this does not match the version that I already have. So the node would either decide to accept that new version, right? Or they would say, no, I'm not going to accept it because this is inaccurate for the data that I have. So in the case of the 51% attack, if enough people in the network, 51% of the network, agree to take this modified version of those 4 blocks, then you now have effectively changed the history of the canonical chain. You still have both chains that exist, but now the network is saying, oh, we're going to take the modified version. And the ability to do that it's very difficult to do that because there are so many nodes that exist. And based on the way that nodes follow the protocol, they typically, when they're given a set of data that is different from what they currently have, they just reject it outright. So that's why it's difficult to actually tamper with the blockchain. And if someone does tamper with it, you can immediately identify that they have.
I also want to touch upon one kind of unstated question. So what actually happens? Where do these weird transactions go? So they actually sit in what you can visualize as a queue. And depending on which protocol we're talking about, whether it's Bitcoin or Ethereum, they will go through a process where they will be queued up for validation. So I'm going to go back to the presentation slides and then just kind of orient ourselves. We're going to actually read the Bitcoin white paper. And I want to start with the Bitcoin white paper because it is more accessible than the Ethereum white paper, because the Ethereum white paper talks a little bit more about the cryptography behind the system and is a little bit more technical than the Bitcoin white paper. So Bitcoin is a little bit easier to dive into, and just to get a sense of, what we had talked about earlier in the first half of the lecture to today now. So sure. Okay, so Alice and Bob. And I know that this is super, super tiny print, so I'm going to basically tell you the gist of what is happening. So as I said before, Alice and Bob are 2 folks that you will hear about routinely as you read in the space. So this is a very, very generalized description of proof of work and how it occurs. So you have these 2 people, Alice and Bob. They are 2 parties who either want to exchange money or some type of record, right? So you can kind of think about this process, the first kind of block, as off-chain governance. 2 through 7 is on-chain governance, where off-chain is usually categorized as the interactions between 2 individuals, 2 humans. We are exchanging something, we want to give that person Bitcoin or that person Ether. So we talk about it. That's a version of governance. On-chain governance is what actually happens after that human interaction occurs. So Alice and Bob talk about how much or what they want to exchange between themselves. Then the verification, the second kind of rectangle, occurs. So the verification process is what we kind of touched upon a little bit earlier, where this transaction is either instantly verified or it's placed in a queue called a mempool. And this is something that you'll read as you kind of look through the Ethereum white paper a little bit later in the course. So as it's waiting to be verified, you have the blocks that are awaiting that transaction. And all the information in the blocks are hashed. So what is a hash? As Val noted, a hash you can kind of think of as a fingerprint, right? It is something that identifies that record, that timestamp, that data within that block. There are various methods to hashing data, but basically a hash digests a piece of data of arbitrary size to a fixed size. So you can kind of think of all the records just as a single kind of size in your mind, as evidenced in this picture. So as the blocks are awaiting this new transaction, you have the actual validation process starting. So this is the process of consensus, through which you either have those various proof of work or proof of stake, proof of authority algorithms happening. And 5 is when the actual mining process begins. So whatever that proof of X that this protocol is using, this is when it begins. And again, what we kind of pointed to earlier today, this process will either take a varying amount of time between, let's say, 10 to 15 minutes or 10 to 15 seconds, depending on which protocol. So kind of keep that in mind. And 6 and 7, with 6, you have the chain. So now that that transaction has been validated, it has been added to the block. And that miner has now been rewarded, and that block has now been broadcast to the wider network. So with that, 7 is kind of what we talked about a little earlier today with what happens with those blocks that may not be included in the actual chain, right? So you could have those uncle or orphan blocks. You could have those blocks that are just not included at all. And that is what this diagram is specifically talking about. And again, you'll have time to view this at a later time, but this is just another general breakdown of a proof of work consensus algorithm. So with that, we are going to look at the Bitcoin white paper with a buddy. So we will come back after talking about the white paper, and there's no need to finish the paper in today's session. The rest of that will be for home review if you want to. And what I want to happen is basically make note of anything that maybe does not make sense, that you find interesting, that may have pointed to what we talked about earlier in the historical part of this lecture. And we're going to come back as a group after about 20 minutes and discuss those topics that we found interesting. I'm going to stop the share and send you all the PDF of it.
So one question that Aaron posed is, who on Bitcoin Core is closest to Satoshi? And is Satoshi really one or many people? I don't think any of us know the answer to that one. But it is a fun thing to think about.
It makes sense when we're thinking about ourselves and like, okay, this is the first thing and then this happens. But when we try and explain it to others, we're all over the place.
It gets better the more and more you participate and interact with the literature. And okay, so as folks start to come back, I know we did not have nearly enough time to read the entire thing. That was definitely not the point of the exercise. Any initial thoughts on the white paper? Did you expect it to look that way, read that way? Any initial thoughts?
I thought it was well written in terms of things were made very simple, that when you read it, you can feel like, oh, I understand what's going on. But as that graphic says, it's not that simple, but I think the paper did a good job of simplifying things.
I agree. In terms of looks, I thought it would be some like 20 pages of some thick text without any pictures, but yeah, it's understandable, simple reading like a chapter in a textbook.
I think reading this like the fifth time, or I don't know how many times I've read it, the difference mainly this time was I was thinking about hardware a lot, just because there's a whole section just on reclaiming disk space that I think I completely missed the first time. And so I was mentioning how like everything's kind of trying to go back to P2P, like the concept of like cold wallets, right, versus hot wallets, and everything always being connected and IoT, just because I think in the era of social media and everything is cloud, and so everyone has all of your data, it's great to see that there was a framework back then that sort of talked about like, well, we can reclaim disk space and this is how it should be or it could be structured ideally.
I found, I think, like the initial sections and like the underlying assumptions and motivations for developing this in the first place really interesting. And it's something like I'd love to explore a bit more, like these kind of assumptions that I'm not really sure like if they've turned out the way that he expected. Like assuming that because the transaction is non-reversible, that like automatically protects people from fraud. Well, as we see all the time, like nowadays, like there are lots of lots of fraud that happens on blockchains. So yeah, I just thought it was super interesting just to think about it as like a replacement for cash as well. And how that has turned out too. It's like just a hindsight I find really interesting.
So this is basically wanted to conclude today with reading the white paper, and I am then going to talk about the deliverable and how to kind of best figure out the learning style for you. So let me stop the share for a bit. I just wanted to show you all the meme. All right, so I only have one required reading for this week, and that is finish reading the Bitcoin white paper. If you can, make note of anything that does not make sense and all of that good stuff that we did in today's group. So I do have a couple of other readings that you can look at if you want to, that being Timothy C. May's manifesto, Hughes' manifesto again, and the Crypto Dreams Part 1 and 2. So those are optional. And there is one other required reading, which is the Distributed Labs Volume 1, pages 37 to 51, and then 172 to 179. So I will say that is a very, very, very technical, oh yes, do not read all 400 pages. The pages I have outlined just those sections for this week. And the Distributed Labs is a very, very good text. It gets into basically a comprehensive guide to what we talked about today and a little bit more about Bitcoin and blockchain in general. So let me know if you have those pages or if you need them. I can give them to you via email or any other way which works for you. All right, any questions on the readings?
So I thought that those readings were posted for today. Are they for next week?
They are for, I would say, I posted them as a reading to orient yourself if you want to for this week. I would say at least have them, some of them read by the beginning of next week, as we'll start to kind of move on from those topics and into another one. So yeah, definitely this is more the self-guided part. These are suggestions, and if you can't or just don't have the time to make it through, definitely schedule some office hours and I'll give you the TLDR of the readings.
I have a question.
Oh, sorry, can I do a follow-up?
Yeah, of course.
I want more readings. I already did those. So.
Okay. I will give out more readings for folks who want more readings. I have a ton, so.
If we have questions that fall under the category of office hours on the readings, do we come to you, Gabrielle, or Val?
Either. I mean, I would say most of my deliverables and lectures are based off of the reading. So if you do have questions about them, you can come to me. Val just said come to me, so.
Yes, I'm not a huge reader. There are some people here who are huge readers. That's not me. I have read some of these, but not all of them. And also I'll talk about this in a second, but the engineering track deliverables are going to be a little bit different.
Thank you.
Yeah.
I also have a book on Solidity Best Guides, which I use all the time in my work, and I will definitely share that with you all as well. Any other cues?
I was seeing a lot of trend with Solidity, but then I came across another language which is known as Viper. It's similar to Python. Do you think it's not being as popular, or do you think the developer community is not as widespread as Solidity is, or is there another community for Viper? Because I'm familiar with Python, but then Viper seems like, yeah, so Viper is similar to Python, right? So I would prefer using that than Solidity.
I would say in my experience, I have only worked with Solidity with the audits that I do. I would say Viper, I believe, is not as secure as Solidity is. I don't know, Val, if you have any experience with Viper.
I don't know for sure about security, but in terms of like the health, I would say, of it. So like Viper is not, there's not as active development on the language itself. And because of that, people have gravitated away from it. I don't know. So Vitalik wrote Viper, or he started it, and I'm sure there's other people contributing to it as well. Oh, sorry. Also, Vitalik Buterin is one of the creators of Ethereum. So he wrote Viper. I don't know if he's actively working on it still. So given that, my guess is that he's not investing as much time in it. And so I think that's why people have kind of gravitated away from it. And at least during the engineering track, we'll be focusing on Solidity. If you know Python, you will grasp Solidity fairly easily. So I wouldn't worry too much about that. Someone also asked, will the recordings be shared, or where will they be shared? So I'll likely post the recordings to YouTube, and then I'll just share the link through Discord with everyone.
Awesome. So for the deliverable,
something else quickly. The readings that you've listed on Notion, were they for just this week, or is that like the total readings for the entire track?
Yes. So under the required and recommended readings, those will just be a list for the entire track. And when you click on the welcome week or whatever week we're on, I'll list at the bottom of I'll just show you the readings specifically for this week or whatever week we happen to be on. So up here, we have the required and recommended readings, and I will populate this with the ones that we will be looking at throughout the course. And if you go to the welcome week or whatever week we happen to be on, open it up as a full page, scroll down to the bottom. Under home review, I will have them listed out with required and then optional. So just to make sure that if you want to read ahead, you can definitely read ahead. But if you want to just stay along with the course, then they will be right there as well. And since we're on—
Cool, thanks.
Yeah, no problem. Since we're on this page, let's talk about the deliverable. So with all of the assignments and deliverables that I assign, I will always put why this assignment matters. I feel like that is crucial for you all as you make your way through learning about the Web3 and general blockchain space. So this first assignment is very, very, I would say, written-ish. You don't have to write if that is not something that you are super proficient in. It can be a visual thing, a video essay, anything that can convey that you've answered this question and thought about it. And this question being, what's the big deal with crypto and Web3 and why should we care? So there are no wrong answers here. I am not looking for a specific canned response. I want to hear a response that's unique to you and your experiences. However, with that, I would like to see some incorporation of the material if you want to, because as you go throughout the space and for the folks who are on the architecture track, thinking about your use case, I want you to be able to use what you've learned to inform a discussion around the final use case that you will be presenting on. So with that, please be as creative as possible in incorporating your responses. Citations don't really matter. I just, I trust that you all will use your own work and cite things that are not your own. So yeah, any questions on that?
Can I insert pictures in like a blog sort of format?
Yeah, yeah.
Or infographics.
This deliverable is for both tracks, yes.
Mm-hmm. Wait.
Well, it's slightly modified for the engineering track. I'll pull that up in a sec.
I'll stop there.
Do you have a length request for the video versus writing?
Yeah, so I will have I have a Dropbox that you can use to put any of the deliverables to me so I can look at it.
But do you have a request for how long you want the videos to be?
No, whichever. If it's short or long, it's cool with me.
Great. So I'll pull up the engineering track one right now. Okay. So what screen am I sharing? Can you see Notion?
Yeah.
Okay. Great. It wasn't clear to me that it was sharing. Okay. So basically under season 0 curriculum, there's a link to the engineering track. We'll also pull in the architecture track underneath here as well. So they'll both be accessible from the same page. And then if you click into here, this is kind of the overview about the program. So because I didn't really dive into too much depth on this yesterday, I know some people are still deciding which track they want to do. So I'll just go cover this briefly now. So basically, if you have at least a year of programming experience, then you're eligible to do the engineering track. We'll cover all the same content in both tracks, but just a slightly different angle. And then, as I mentioned earlier today, there will be weekly coding deliverables for the engineering track as well. So requirements for the track, you need to have access to a computer that you can develop software on. I recommend using a Mac or Linux as your operating system. I'm not a Windows person, so I won't really be able to support you if you're using Windows unless you really know what you're doing. But if you want, we can provide an EC2 instance with like Ubuntu so that you can develop on Linux as well. And then I just added like some of the dependencies that you'll need for the program, but we can come back to that as we get set up next week. And then also you should have a account where you can share your deliverables online. So that could be GitHub, GitLab, Bitbucket, wherever you want to, whatever account you want to use. All of the code that we develop will be open source. So for the deliverables for this week, open this up larger. So it's very similar to what Gabrielle already mentioned. So you can create an article, could be a video, could be an audio like in the form of a podcast, could be a tweet thread, whatever kind of version of producing something and publishing it out into the world you want. All of it should be public in the sense that it should be accessible to anyone. And then once you actually create that, you'll just submit a URL basically to what you've created. So the questions are very similar, like what's the deal with crypto and Web3? Why do you care? Why should other people care? Include some examples from what we talked about today, the readings, your own experiences, conversations that you've had. Explain like what a blockchain is, why it's something that people might want to use, and then include additionally like your personal learning and career goals. So what you kind of hope to accomplish out of the next few weeks. And then also included why the assignment matters. And then lastly here at the bottom, it's just the forms that you should complete. So both tracks actually should complete the feedback form, and we'll send that in an email right after this session. And it's just a simple type form just to collect some feedback from you on how this weekend went. And then in addition, a form for the deliverable. And again, that's going to just be a URL that you'll paste in for what you created. And that will be due on Friday. And then we will do peer review of all the submissions for that deliverable on next Saturday. So any questions about deliverables for engineering track so far?
There is a question about attending office hours. Is that for which track?
I guess, office hours are usually held physically. So is there like a Zoom room that we go to, like an address for a video room that you're going to be in, or how does that work?
So yeah, for engineering track, it'll just be on Discord. So for mine, it will be Monday, 7 to 8 p.m. Eastern, and then Tuesday, 9 to 10 a.m. Eastern. And there's a Discord link right here, and you'll just join that, and I'll be in there and we can chat.
And architecture track will be held over Google Meet as just filling out the Calendly appointment, and it'll send you a link. Yes, and they can be as short as literally 2 minutes. Like if you have nothing to talk about, I will set you free. The reason why I have the office hours weekly is just to make sure that you are on track. And I know for me personally, I always get super nervous asking questions to a group. So that's in place for folks who may have questions that they may not feel comfortable with asking to a larger audience. So that's why that's built in there.
I also see the question, are they mandatory? Okay, you already just said that. So Aaron asked, do you recommend the Consensus Academy for engineering track? So yeah, a few people have asked about this. So Consensus Academy starts in late September, I think, or no, early September. So it'll overlap a little bit with this program. So far we have all the scholarships that we had available are already taken. So we can't give out any more scholarships, but if you're still interested in doing it, my kind of take on that is it's very deeply Solidity. So you'll learn entirely about smart contract development, but it's also very hands-off. So they don't have like live sessions like this. They do have office hours, but it'll be watching video recordings and kind of just going at your own pace mostly. And then it also runs until December, so it's a much longer program. So I would say if you really want to do smart contract development, it's a good thing to consider. But the success or the graduation rate is fairly low because it's not very high touch. So if you are the type of person who's very much like a self-learner, then I would recommend it. If not, I might consider other programs. And additionally, if you are one of the people who got a scholarship through us, we will have required weekly check-ins. So we'll be I'll be there basically to support you as you're going through the program. Any other questions? Yeah, go ahead.
Not a question, but do you mind putting that link that you're looking at in the chat?
Yes.
I think you shared it, but I can't find it.
Yeah, no problem. There's a lot of links. So
Thanks.
I know it can be hard to keep track of everything. Okay. Yeah, I think that's it for engineering track. Is anyone still on the fence between the two? Does anyone still have questions between the two? Okay. If you do have questions, you can, well, actually, we'd like you to decide by the end of the session today. And in the feedback form, it will ask what track you're a part of. So you'll just indicate it there. And then also in your deliverable submission, it'll ask what track you're a part of. So basically within the next, day, try to figure that out. Additionally, the feedback form is anonymous, so you don't have to include your name. We don't collect your email on that. Please be as honest as possible. That's just going to make us make the program better. And then I guess the last thing that I wanted to say, and I'll let Gabrielle wrap us up after this, is today might have been overwhelming. There's a lot of information presented. There's a lot of material to go through. That is okay. Our expectation is not that you get it immediately, especially if this is a lot of material that's unfamiliar to you or that you're hearing about for the first time. But really what we're trying to do is create a space where you can go through those challenges of learning this stuff with other people who are supporting you. So it's never easy to learn a new thing, especially something that is like evolving all the time and drawing from tons of different fields, both philosophical fields and economic fields and mathematical fields. It's complicated stuff, but the point really is that you have a space to do that work that allows you to be productive. So don't feel like it's supposed to be something that you get right away and is super easy. Like that's not the expectation at all. But we want to just kind of like help you in your learning journey.
Yeah, and to just echo what Val said, it takes a while. I started in the space in 2018, and I read some things here and there and kind of got the gist, but it didn't really sink in until much later. I also did the consensus boot camp, and I would say, echoing again what Val said, it's definitely a course for folks who learn best through self-learning. I do not have a coding background, so there was a lot that I had to teach myself in that amount of time, which I got through it, and it has been an asset to me, but I would also just think about the style of learning that works best for you. And yeah. Also, we're here, so if you have any questions, I am happy to answer them or like walk through anything between what we talked about today, other outside topics that may not be super relevant to what we talked about today, or just career things in general. So we're here. We have a question about a Discord thread for possible reading studying groups.
Yeah, so I would say feel free to use the Season 0 channel as a way to communicate with each other and do study groups. We have a few voice channels in Discord called Cowork, and you can just jump into those, share screen with each other, collaborate, and we encourage you to do that. It's going to be much easier to learn this stuff if you're doing it together. So feel free to just say, hey, if anyone wants to chat, let's meet at this time and go ahead and do it. And if you do need more channels or something's not working with Discord, definitely let us know. And we'll try to make sure that that space is as conducive as possible for group learning as well.
So I think with that, I'm going to save this amazing chat so we can have all the links that we discussed from today's session. And also congratulations, everyone. This was a lot of information. So happy to start this journey with you all. So thank you.
All right, so we'll stick around for another 5 minutes if there's still questions. If not, thanks for being here. It was a great weekend getting to meet you and starting to dive into this stuff. We'll see you next week. You'll receive a follow-up email shortly with the link to the feedback form. And as always, let us know if you have questions. We're here to help.
Is there a link for the architecture? Or like, are we allowed to like peek at some of those resources if we're not in that track? I just like reading. So I was just curious.
Yeah. I mean,
oh, go ahead, Gabrielle.
I was just gonna say, the Notion will be, I'm gonna put it in the public field so folks can see it. I've just been very, just haven't gotten around to doing it. But yes, after today, I will post all of that there and give folks the folder of other research that I've looked at if folks want to do some more reading.
Cool, thanks, Gabrielle. And last announcement, I did invite a bunch of folks to the Women Who Code blockchain channel on Slack. Didn't receive like an email from me, you just ping me your email on Discord, and I'm happy to add you.
That's great. Thanks for doing that. Yeah, that group is really great. And yeah, just to kind of reiterate, all the material for both tracks will be available to everyone. So if you do want to peek or do some things from another track, you can on your own time. We're happy to have you do that.
Thanks so much. See you next weekend over
Yeah.
office hours.
Yeah.
Bye.
See you soon. Bye-bye.
Okay, I think that's it.
Success. We made it.
Did it. Week 1 done.
Yeah.